So liter, like vector,
Yeah, liter is like vector. I'm sorry.
right?
I'm sorry. Yeah,
Like
yeah.
this one, but your explanation. Okay, what is it? Gets amount.
What is get gas amount?
Yeah.
What is 哎，对，我是我是觉得说 get amount 只是一个可以用的 function，然后 liter 是它可以传进来，就是需要做到这个东西，传出去的一个算是像是 int 那种的型别这样。
Mm, not. Okay. So here, car cannot get it
好，靠，
by itself. So
哦，
ask leader to do it.
靠，
Similar. Similar. Yeah. So ask leader. So leader has the matter. And leader will define the value attribute. But car as leader, right? So this concept, I hope that you can understand that. We call this as anyone can tell me to finish the word. Get on?
Dependency.
You can finish the word.
Delegation.
So delegation. Delegation. Right. So there's a delegation. You want me to delegate because I cannot do it. And I ask, probably I can do it. But it make my responsibility, to meaning of that. So we restructure that. We take all these parts, right? Delegate to someone to do it. So this is delegation. Right. And here it's about we know that there's a lot of good way that inheritance can have. It's easy to reuse, right? And we can have overriding, right? Make a difference. So make a difference. It's overriding. It happens the inheritance, relationship, right? The other polymorphism we said that is overloading, make a difference, but it happens within the single class, right? But here inheritance also will raise a couple of problem, right? So we call it's a kind of misuse, right? So here is a semantic consistence problem. What does it mean in this diagram? Semantic consistence problem. It happens often. Inheritance. Larissa, can you answer this?
Is it the compute page is the difference meaning?
Mm-hmm.
One is for the customer is for the pay one,
Mm-hmm.
and employee is for the pay for the salaries.
Mm-hmm. Yeah, so they're different. But
Yeah.
use the same name. It's
Yeah.
easy to confuse. Right.
Yeah.
So here, semantic consistency problem, we presume that if we use the meaning, it should be the same, right? But employee, the company need to pay the salary. But customer, customer need to pay to the company, right? So there's totally different. If we use compute pay, inherits from person. Of course, you can override it, right? You can override it, but confused, right? Some programmer may misuse it because they use the same name, right? So it is likely that we might misuse it. So semantic consistent problem, right? And also you can see that here. Let's go very deep, all right? Narissa, what's the problems of this?
The every day of the class need to override.
Pardon me. The what?
Every new class need to override.
Mm-hmm. The need to override it. It is allowed to have overridden, right? It is
Yeah.
allowed, but not necessary. Everyone need to override, all right? We can take it for granted. And what's the problems of inheritance conflict?
It's hard to maintain.
How to maintain, because you just said that it could be overrides and overrides.
Yeah.
All right. Yes, and well, it turned out that if it's the bottom part, that's it's already overridden. All right. So it's it's easy to confuse that which which one. So a lot of can be paid, but they are all different. All right. So eventually you may not understand what about the compute pay of the doctor, right? Because you need to trace what salary the employee probably this. So override is different. So it just start to make a difference, or inherit the same from salary employee. But actually, salary employee overrides employee. So if you go deep, then you gotta trace. That's raise the conflicts, right? Inheritance conflicts. And this one, Elton, explain this. Consonants are synonym and harmonym. Answer. What does it mean? Consonants, synonym and harmonym. Based on this diagram, what can you see? Raise your hand if you understand. Corinne?
Have same attribute.
Tell it then. Attribute?
The same.
The same attributes? Which one?
Employee and robot.
Employee and robot, right? And so what can you see this diagram? The diagram, robots, employee. How many parents of a robot employee?
Two.
Two. And some programming language were not allowed.
Mm.
We call this multiple inheritance, right? So what's the problems of employee and robot? You said name, right? They are the same.
Mm.
What's the problem?
Harmonious.
Harmonious? It's a homonym. Homonym.
They have same name but different meaning.
But appearance, name and name is the same. Same meaning.
Oh,
Which one? Which one is a homonym?
running time.
Okay, wrong time. Same, but different meaning.
Yeah.
Yeah, we'll calculate that the employee and robots is a difference. Right, it's homo the same. Name. Whoa. What about the others? Katie, synonym. Which one is synonym?
It's class, infection, and type.
Classification and type.
Yep.
Oh, why we call it synonym? What does it mean as a synonym here? You say classification and type.
Yep.
Do they have the same meaning?
Yeah, they have same meaning.
But
It
if-
means this two class type, and it means the same.
Okay, so classification and type means the same, but
Yeah.
use different words. All right.
Yes.
Okay, synonym, they're the different words, but different form. Same meaning. Right. Usually when we write, we like to use different words. Means the same because it make the content more vivid. All right, we're not so dull. Use the same word again and again and again. So we'll change words. That means the same, similar thing. All right. So here, synonym, classification type. What about robot employee? Which one is going to use? So either the same. No, it's the same. Some programming language allow to have multiple inheritance. All right. So suppose that the programming language, allowed to have that. And Harry, what is homonym? No, what is fuzziness?
Firstly is name, and this
Okay,
name
tell me.
is they have the same name and the same meaning, so they are fitness.
Say it again. They're the same then?
Yeah.
Yeah, they are the same.
Yeah.
And what does it mean, fuzziness?
Fitness. It means
Yeah, it's the same meaning, same words, all right? But
Business is same name and the same meaning, and we use the name, but we don't know it belong employee or robot.
good, yeah. So because we said that's inherit from two parents, which one? Is it the name of employee, or we should use the name of robot? Since here we have robot employee, right? Inherits more than one parent, so a lot of things should be cautious, right? So that's why some programming language, would not allow to have multiple inheritance, because it is very easy to cause the falseness. And what about the same meaning but use different words, or same words means different. The way to define is a little difference. So you will raise falseness, synonym, and homonym. That's why we said that, well, that's a problem, right? So problems of inheritance, it could be multiple inheritance, but of course, if you use Java, then there's no this situation. It's not allowed to have multiple inheritance, right? Well, one question to you that's, if you see there's a multiple inheritance, then you wanted to change to single inheritance. How can we change this? Harry?
The robot employee inheritance from employees, and robot employee and robot is association.
Oh, pretty good. Yeah. So we change either side. All right. Change one side as association, then it become single inheritance. All right. So it happens if you wanted to transfer from multiple inheritance to single inheritance, you need to change. You keep one, right? You select one. The same, keep its inheritance, and the others you change it, right? From association. Okay, let's take a break here. Let's proceed. Get three important issues. One is coupling. So we just talk about coupling, right? Coupling. So it might happen any situation if two matters wanted to communicate with each other within a class probably, or different object they wanted to communicate, right? Request and provide something, right? Coupling may happen everywhere, right? Cohesion. Now we look at one single mind. Is a single-minded. It's a single. We wanted to know that how single-minded a module is within a system, right? We wanted to know that if we create all the employee, then everything within all the employee, that's highly related to this class, right? So that's why we wanted to take out some not so related method or attributes out, right? In that situation happens, then this one, it happens that you wanted to do something and ask someone to do it. It's a concept, we say there's a delegation. But it will be easier to maintain that class, right? That class, because it's quite simple, right? Can be reused in different situations. You make the class very, big. It's hard to be reused, right? So then we look at cohesions of these components. It's high coherence, right? So it's very high coherence, highly coherence, high coherent, cohesive. And we look at them both, we keep them balanced. So usually it's have a high coupling and low cohesion. Usually, I said not always. A high cohesion or low coupling, right? So try to balance that. Depends on your design, which one you care most, right? Oops. Because when the object has some relationship, we change the one will affect the others, right? Affect the dependent, because it depends on others. If we change, right? We change is one. If A has B, right? If A has B, then Helen. If A has B, then which one we change will affect the other? A has B. Which one, A or B, change, then will affect the other. A has B. Which change the one will affect the other? Which one? Say it again. A has B. Then we change A will affect B, or change B will affect A.
So A change B.
A change B. We wanted to change A or B. If we change A has B. Which one change will affect the others? Okay, yeah. A and B. Which one change will affect the others?
B 劝句 A 会受影响。
So when we change this, what affects, right? What affects stack? What about this? Which one change will affect the others?
A 劝句 B 会被受影响。
Okay, so that's different, all right? So keep in mind that when we change a relationship, then the impact will be different, right? The targets. So we stack has vector change will affect stack. But if stack is a child, we change parent will affect. So you change the relationship and you change the impact. All right. And we also know that UML, right, their relationship is non-transitive, right? So dependency, not transitive. If A depends on B and B depends on C, right? B depends on A. And this one depends on the others. All right? Stack may has something, right? Not necessary. C depends on C. If it's A, B, C. So non-transitive. A depends on B depends on C. I said depends, it could be inheritance, could be, different kinds of OA. And it's not necessary, A depends on C. It's non-transitive. Coupling has two kinds. It's interaction or inheritance. We'll talk a lot of inheritance. So this is non-inheritance interaction, all right? So coupling may happen inheritance interaction, all right? So about these two kinds of relationship, we call this coupling because they have some, dependency, all right? Interaction coupling, inheritance coupling. So leaders, to understand that LOD, load of the meter. LOD is 4, right? Previously, we probably would see that's 5, but in Java, we take out the fifth one. So there are four principles, and there's load of the meter. All right, and we're going to see that their interaction. They involve interactions, coupling, and inheritance coupling. Right? And the way is to minimize coupling. Right? So minimize that means that only talk to your close friend. Don't talk to strangers. Right? It says don't talk to strangers. Only talk to your close friend. It's close friend. So talk to you don't need to pass as very long, right? So minimize the coupling. Let us say that. It's inheritance coupling, right? And we know it's already discussed the problems of inheritance by using vector and stack, right? Also I discussed this. So whatever if they have some relationship, all right, they need to conform to the contract established. For example, here we might have a redis, linked list, and vector, right? Well, they have a contract with list, but they should follow whatever list interface. It says avoid getter and setter. It doesn't mean that we don't use it. We don't use it at all. It means that avoid getter and setter, that we should use it, right, in some appropriate situation, all right. So the reason we have gets and sets because we wanted to manage that, right. We wanted to reveal the value, the attributes and method. We said it's all public, no problem. So getter and setter, this two consideration, we can combine stats, become 4, it's a 4 combination. We said it's all public, right? So when we said it's all public, that means that no secrets at all. It is supposed to be open to everyone to use that. So we said it's all public. Oh, we think that we will keep the change value as a secret. So set it set as private, but we're going to open get, right? Set get as a public. And the other thing is, well, internally, we wanted to, we don't, what did I say that? If we set as get as a public, then everybody can view it, can get it, right? Get the value, right? Get, because that is public, but we don't want to allow the outsider to set it. So the sets as private, and also we can reverse that, right? You can change the value, right? Change value, right? But we set get as a private, you cannot get it. That's rare. And also set as internal transaction, right? So set as all private. So getter is that as don't misuse that. You said so public or whatever. It depends, right? When you wanted to apply to some situation, that will allow you to consider how to set the getter and setter. So this is about the method, right? The method that how to set this. I give you this and ready. The coupling may have no dependencies. Each one depends on self. That's if it is a system, right? Usually you will not see that's probably have no direct relationship, but if there's no dependency, usually we will not see that in a system. If one's island, no. Isolates island, no, right? So the first situation you will not see that in a system. No dependencies, no, right? Usually we hope that we can design by using couple, right? It's loosely couple, right? Loosely couple. It means some dependency. If it's a highly coupled, it's no good design, right? Because you have a lot of dependencies, right? For each kind of coupling, right? It has this situation. We may make it better if necessary, right? So everything got a situations of dependency or relationship, right? Like we wanted to press an order, right? Order pressments, press an order. So you think about an order. The order, when you press an order, it raises some issue. When somebody wanted to press an order, wanted to order something, it probably said, I want to order 50 items, right? Or one item, 50 pieces of that. Right? You got to check out your inventory. Do we have that? Right. So inventory. So there's a relationship with inventory. You got to manage your inventory. If you cannot provide enough pieces of that, then you should notify customer. Right. On the other hand, inventory, quantity will change. If we don't have enough item to provide, we may order, right? So here, supplier, we send the order request to supplier. So that's a relationship. And also, we need to set a price. So it says item pricing. All of that seems, no. When you press order, then you have all the thing, right? Probably wanting to reject the order, right? One of that is out of stock, out of service. Well, the supplier says they don't have that mechanisms, or they don't have that one, right? So you need to notify the customer, right? So if we do have, and the customer, we still need to check. What about the customer's credits, right? So we need to keep a credit history of customers to see that, well, the credit of customer, that's good. So customers' credits and our inventory know, both say yes, then yeah, we accept the order. Either side is not yes, then probably we want to reject it, right? If customer credit is very bad, then we reject the order. Whatever we have, we hold it in our inventory. We still reject the order. So you can see that present orders are a lot of issue we need to consider, right? And but here, even though we think that there's some relationship, right? It says loose coupling. We wanted to apply law of Demeter, right? So law of Demeter. It says email notification, inventory management. Well, it says these components are cross-friends. When you change inventory, right? We do have that. Then we send notification to customer. We accept the order, right? That's. Or we don't have that. Then we send notification to the customer. Said that we gotta wait, right? Probably wait for having a month. That's right. So it says email notification. These two are related, and you can see the cross sign here. Item pricing, supply ordering. It says well, these two components are neither friends or neighbors of order placement. So these two, you don't need to couple that. All right. So inventory management coupled with supplier ordering coupled with item pricing doesn't mean that item pricing should couple with supplier ordering, right? And let's see the 4 rules, right? So it says principles of that. The first one, to itself, we look at one component, all right? So if we need to execute a task, right? And one, these components can do it. It means to itself, talk to itself. If you talk, you behave. So here involves an issue that talk to yourself. That means you have two methods, right? They wanted to talk with each other. So we talk about coupling, more than one. But here, there's a host, right? But talk to this out. That means method talk to method, right? Within a class, right? So method talk to method. Without this kinds of communication, then we cannot execute the task as a tool to itself. The second, right? So not just one, right? The second one said that, well, we need to consider inheritance coupling and interaction coupling. So I cannot do it myself. I cannot just talk to myself and fulfill this task. When I wanted to do it, I asked for help. Right? I asked for help. So here, that is a coupling with others. So coupling with others. So like I ask you the question that when this object has another object, right? And asks another object to do it. So usually we will set the object as an instance variable. So we wanted to do that, right? We need to hold it, right? That's so here is interaction coupling, and the other, as we said, that well, it's so good that the parent has this, you just inherit it, or you have a child, pass this on, right? Pass this on to your children. So it came from inheritance coupling or interaction coupling. Then we can fulfill the task right? That means that I cannot just depend on myself and need to ask for help. The one way is that I have instance variable, right? And the other is I can pass this on to my children, or I can inherit from the parents. Easy. The third one is, okay, we wanted to ask you that here this is a matter, right? So I wanted to conduct this, and I put my helper as a parameter, right? So here become a parameter and ask this to do something. It's easy. The third one. The fourth one, that's okay. Well, I need that, then I create it. I created as my production. Okay, the ones I produced to do the thing. So all the communication may happen from any of that situation. All right. So it says, first one to yourself. You can pray with yourself. All right. So pray with yourself. Talk to yourself. You want it, not just talk that for fun. All right. You want it to finish a task. You need to finish a task, and they need to cooperate with each other. All right. And the second one, you can pray with your own toy. So your own toy, you take it as instance variable, right? And that involves interaction or inheritance. The third one, you can play with toys that were given to you, right? Given to you. So you set as a parameters, from the parameter given, it's a gift to you, right? And you can play with toy. You made it, you produce it. Your production, you produce it yourself, right? So there's a raw dimeter here. And so I wanted to ask that, Jerry, from the diagram, tell me that if I wanted to apply the third principle of raw dimeter, and tell me how to apply it. The third. Shane, the third. From the diagram. Yeah, we wanted to apply the third, ROD. Richard, can you answer this? Hank, can you answer this? You want to apply the third. ROD. Yeah, we have fourth, right? First, second, third, and fourth. If we wanted to apply the third. LOD. Which one you can tell? Not easy, but you know. So raise your hand if you understand that. Raise your hand. Not easy. Yeah, not easy, I know. Third. Raise your hand. I know it's just not easy. Think. The third principle. It could be very difficult. Okay, yes, Carol?
I think the request is LOD3 because the argument is object.
Is it request? Request what? Which one?
Left upper.
Is it this?
Yes.
Request appointments?
Yes.
Why? What do you think? Request appointments. Explain that.
Okay.
Explain.
I think the argument is an object because because the definition of LOD3 is the argument is object
Okay.
and send it and
What
to
object?
I think address maybe is object.
No. We don't have that object. You can see object. No. No. Okay. Do you understand that? No. Yakera ATA. No. Tell us. Request appointments. Yes. Change that. Make it become a third. Change that. How do we write a code? Yes? You know how to do that? Code. Code. I like to. You get care?
I think I can change the argument to a patient.
All right. Patient and
Patient and the receptionist.
receptionist.
Oh, sorry.
Patient, yes. So
Okay.
patient, okay?
Mm.
And give it variable. Give it a variable.
A variable.
Yeah, variable. Give patient a variable. Anything.
Mm.
Anything.
Anything.
Yeah. Patient. Can we give it a P? Can we
Okay.
give it a P?
Yes.
Okay, and finish that. All right.
Okay.
So,
So
request appointments, patient P, all right?
yes, patient
And
P.
finish that. How can we make patient to do it? Can we make patient to do it? We cannot get it? Very possible. Make the patient do it. Tell me, how can we make patient to do it?
Appointment.
So now we need to change that request appointments, patient P, all right? But here, remember that we need the name and address. It's easy. Easy. Patient P, all right? How can we ask patient to do it? Easy. It's easy. Corey. Corey, whatever you can say, all right? All right? Customer? We don't have customer. We don't have customer. We only have stats. Patient. Patient.
I guess is this name equal patient the name. This address equal patient address.
No, not under that. Think about get a setter. It's not difficult. Not that difficult. Get a setter. Okay. Alex, you understand that? Hank? Shoot. Shoot. No. Okay, now request appointments, right? Then we ask because we want to put it as a parameter, right? To ask patient because the patient holds the information, right? Patient has name, probably ID, address, all right? So patient has that, we ask patient to do it. So it is a patient P, and ask patient get. All right, it's easy. So we ask the same as gas amounts, right? So we wanted to get name from patient. Ask patient to get it. So patient itself, patient is ID, patient can get. All right. Patient can set its name, can get its name. All right. Because then we wanted to set, it become private, right? Only patient can set the name and ID address, but the other as to get. So it's not that difficult, right? So here, that is the third one. Penny, tell me the fourth one. Yeah? Which one? Which one will be the fourth? Louder. Okay. LD4. Yeah. We have the third. We have fourth. Which one is fourth? No. Tell me that. Which one is fourth? Alex?
I think it's diagram B, the invoice.
Diagram B. No. Fourth. Okay, good. Mental.
So we
Louder.
diagram C, create an activity. So we create an object.
Yes, good. Very good. All right. This. Create appointments. So we create something. So price LD4, right? LD4. So then we can new it, right? We knew this. So here, create, right? Create appointments. So it depends on which ones. And remember that we don't have receptionist. It is a GUI, right? It is a GUI. So we might have the page. That's a GUI. And here we don't see controller. So everything GUI need to do it. We don't have DB manager, so GUI need to do it. All right. If I give you a picture without GUI, but we have controller, It's not correct. All right. So you got to tell me what's wrong, right? It'll give you control the DB manager without GUI. No, we cannot do it. Right. So here you can see that we can third and fourth. And what about, okay, what about if we wanted to apply the first one? First principle. Okay, Alex, first principle. That one A, right? The top left. And okay, come in, give me an example of that. How do we apply it? So tell me that. The top left. How to apply LOD1? LOD1. There we have object 1, alright, is that a message? What does it mean? That's it. You get them know that, well, you understand how to apply LD1. LD1.
Is that object one send message to itself?
Yeah, and give me the how many message? So going to see.
How
Send
many?
itself. What do you mean by that? Send message to itself. Send a message to yourself. Everything is a message. You wanted to get something, right? If object 1 is patient, get name, right? Send a message to. So get name that means LD1.
Get name means
Because that's just a name. Get name. Instead LD1.
if the name is if that is a patient trying to get the
Mhm.
name, that is OD1.
No.
No, okay.
No. It's an example to explain LD1. Guys, this part. Jimmy, can you understand that? LD1. I said we only get name. No, it's not. Not that easy. Talk to yourself.